Ever wondered how data scientists create a linear regression model? It's like crafting a perfect recipe, with each ingredient carefully measured and added at the right time. So buckle up as we journey through the intricate process of creating, fine-tuning and interpreting a linear regression model. The first step is to create a linear regression model is to understand the problem at hand. Let's say a data scientist is working for a company that wants to understand the relationship between their marketing spend and sales. The goal is to figure out whether increasing the marketing spend will lead to an increase in sales, and if so, by how much. This is where linear regression comes in. Linear regression is a statistical technique that allows us to understand the relationship between two variables. In this case, the two variables are marketing spend and sales. The data scientist would collect historical data and on these two variables and use that to build a linear regression model. Once the model is built, the data scientist needs to interpret the results. The two key metrics here are R square and the adjusted R square. The R square tells us the proportion of the variance in the dependent variable that is predictable from the independent variable. In simple terms, it tells us how well our model fits our data. However, R square has a drawback. It always increases as we add more variables, even if those variables are not related to the output. This is where adjusted R square comes in. It adjusts the R square based on the number of predictors in the model. It increases only if the new variable improves the model more than what would be expected by chance. Now, what if two or more variables are highly correlated? This is known as multicollinearity, and it can be a problem because it can inflate the variance of the coefficient estimates and make the estimates very sensitive to the minor changes in the model. The result is that the coefficient estimates are unstable and different to interpret. Data scientists use a technique like variance inflation factor (VIF) to detect and address multicollinearity. Finally, to fine-tune the model, the data scientists split the data into a training set and a test set. The model is built on the training set and then tested on the test set. This helps to ensure that the model is not just memorizing the data, but it is actually learning from it. In addition, the data scientists use a technique like feature engineering and weight of evidence (WOE) to improve the model. Feature engineering involves creating new variables from the existing ones, while WOE is a technique used to transform a continuous independent variable into set of groups or intervals. In conclusion, creating a linear regression model involves understanding the problem, collecting the data, building and interpreting the model, dealing with multicollinearity, and fine-tuning the model through techniques like training, testing, feature engineering, and weight of evidence. It's a complex but rewarding process, much like crafting the perfect recipe.